It's not much to look at in the laboratory, but hydrogel has the potential to save millions of lives. It's the creation of scientists at the University of California in San Diego, and it's designed to repair tissue damaged by a heart attack. When a heart attack occurs, the body cannot repair damaged tissue on its own. Instead, scar tissue forms, leaving the heart permanently weakened and more vulnerable to future attacks. But with hydrogel, bioengineer Karen Chrisman thinks she's found a way for the heart to repair itself. She says the gel can be injected into the damaged parts of the heart after an attack. There, it forms a scaffold for new cell growth instead of scar tissue.
Once it goes into the heart, it sets into this porous and fibrous scaffold and replaces this extracellular matrix framework that has been removed after a heart attack. The body degrades it initially, and so here we come in and replace it with actually a cardiac-specific extracellular matrix framework, and that promotes cells to come into that area and changes that negative remodeling process that happens after a heart attack.
Chrisman says that negative remodeling is the big reason why more than 7 million people die each year of heart attacks. Jean Wang is a graduate student working on the research. She says the ingredients for the new scaffold come from an unlikely source.
We start by getting a pig's heart and we chop it up into tiny pieces, and we put it into these beakers with detergent in it. And as it's spinning, the detergent removes the cells from the tissue so that only the proteins are left.
Those proteins are then milled into a powder and treated with enzymes that convert it into a liquid. Chrisman says these liquid proteins turn into a gel when introduced into the body. Initial trials conducted on rats and pigs had promising results. The gel successfully formed a foundation for new cell growth. Researcher Todd Johnson says the hydrogel's uncomplicated design makes it easy to handle and administer.
The material isn't, it's not considered living. It does not itself have any cellular components. So it is something that can be easily stored, shipped, and maintained, and then readily prepared for injection. It's something that's very easy to work with.
Chrisman hopes to start human trials within a year. She says her goal is to give heart attack victims a better chance at survival. Ben Gruber, Reuters.